So we will be heating the sodium chloride gently and then a little more strongly, and you'll be able to make your observations here, okay, as to whether there was any effect of heating for the sodium chloride under lab conditions. Okay, if you look at this, you're going to see a little bit, you can make some observations as to what you will see in the test tube. The black soot is coming from the initial luminous flame of the Bunsen burner. The Bunsen burner went out shortly after we tried to switch it to the non-luminous flame, okay? But you'd also be able to see in the test tube to make some further observations. This is for sodium chloride. Next, we're going to move on to sucrose. So again, I'm going to take sucrose and I'm going to put it in my test tube. And I'm going to heat it gently in the Bunsen flame. And then I'm going to heat it a little more strongly. Okay? I want you to get a very close view and to make all the observations as to what happens here. Okay? So what happens here? You see the brown, and you want to make a note. This happens in cooking. So I want a name for that browning of the sucrose. Sucrose is our normal sugar. And there's a name for that process, especially in cooking, that we call it. If you can put an explanation behind that in your discussion for me. But what we're supposed to look at right now is whether there were any changes on heating and what the changes that occurred would have been. Okay, I'm going to move on right now to the last substance for us to deal with, which is going to be iodine. So I'm going to take a little bit of this iodine solid, not a lot, okay, and I'm going to put it inside of my test tube. And you will see that I'm just putting a little bit of iodine inside it there. It really is not a lot as well, but you're going to see from the small amount of particles that are in there, when I expect a big change. So I'm going to heat it. So it went in as a solid. Please note all the observations. Okay. And I'm going to heat it a little more strongly. Okay. Heater to try to heat all sides of my test tube. Usually when we're doing heating experiments, we will use boiling tubes. Okay? Alright. Please make your observations at this point. What changes did you see occur with the heating of the iodine? Is it that the bottom is looking a little lighter in color compared to some areas of the top now? Those are very important indicators. So tell me, what are you observing, okay, in terms of how the substance looks? I'm going to turn off my flame now, and I'm going to proceed to another experiment. Okay. What I did here was to have my sodium chloride, sucrose, and my iodine already dissolved in some water. All right? So I'm going to show you very carefully and closely. I don't know, I hope Miss will be able to get a close-up view there, right? There are no particles of sodium chloride dissolved inside of there, which means that the sodium chloride is readily soluble in the water. Okay, I'm going to take this back. This is sucrose. Okay. Sucrose is also quite readily soluble in water. This, on the other hand, is iodine. Now, our eyes are not deceiving us. We do have some brown occurring there, which means that there is some iodine scattered in between the water molecules there, which means that it is very, very slightly soluble. Now, iodine, as you know, is a covalent substance and should not ideally dissolve in a polar solvent. But there may be a reason, so I want to hear from you what you would think would be the reason for us having some slight solubility of the iodine in the water. at this point, I'm going to move on to the next part of our experiment, which is to test the conductivity. Okay, so I have here my setup where I have my bulb. The bulb is not working today, so you're not going to see any bright lights shining. My setup here, so you can also draw this if you like, and this is my ammeter. My ammeter is going to give me a reading of the amount of current that is flowing through the circuit, all right? So ideally, it will give me an indication as to the amount of electrons that are flowing through this part of the circuit, not inside of there, okay? I'm going to put my ammeter inside of the sodium chloride solution. And I don't know, Miss, are you picking up that at all? Yeah. Right? There's a reading there. What does that tell us? So does sodium chloride conduct electricity? I want to believe you know the answer for this. Okay? I'm then going to move on to the next substance. I'm going to just give my electrodes a brief rinse while Miss is just recording what is going on there, a beautiful setup. And I'm going to come back here. And I'm going to try to see if I can get an ammeter reading for my sucrose in water. Okay, let's see. Sucrose in water. Wow, look at that. All right. Are you all seeing that? Sucrose in water. It's not looking too dramatic. All right. The last one, I'm going to give my electrodes a brief rinse again. And we're going to take a look at my iodine. All right, I am waiting for the drama to unfold here. Somebody tell me if you're seeing any drama unfolding. Looks pretty flat to me. Okay, so that is the conduction of the sodium chloride, the iodine, and the sucrose in water. Next, we're going to go on to looking at what happens with alcohol. Our choice of alcohol today is ethanol. Ethanol, as you know, is a covalent substance. Okay? And being covalent, there are certain characteristics that would be involved in what can dissolve in it. So let's take a look. This is what happens when sodium chloride is dissolved in ethanol. Are you seeing anything at the bottom there? Tell me if you're getting anything going on there, all right? Wow, look at that. And that was stirred quite a lot. Let's see, is this going to conduct electricity? Let's see. I rinsed my electrodes. Oh my gosh, this action story is not actioning. Just not actioning. Okay, I'm going to give my electrodes a brief rinse. Action story seems pretty clean right now. All right, let's see. I'm going to go on to check out what happens with my sucrose. Is my sucrose going to be any better? Miss, are you seeing anything going on there?
Slight.
All right, is there movement? Let's see. I'm going to try it again. This is sucrose. Does it conduct electricity? You tell me. Okay. And the last one, oh, I didn't show you though. Look at what happens when you dissolve the sucrose in the alcohol too. All right. I think I'm going to try to give it a further, and see what happens, because sometimes it's not readily soluble apparently, but there was, and if you can, what you can do to compare, you can pause and you can screenshot and you can take your pictures and compare before and after, right, and see what happens. Okay, so it's not really readily soluble, I would say, but there probably is a small amount of solubility. You tell me, you be the judge. Okay, the last one, as we round up this, is going to be looking at the conduction of iodine. Iodine in alcohol. Now, you remember what iodine looked like when we tried to dissolve it in water, didn't you? If you don't remember, this was the attempt to dissolve iodine in water. This is what happens when we dissolve iodine in ethanol. Wow, great difference. I want an explanation for that. What do you think is going on there? Okay, so I'm going to try, let's see. Is my iodine conducting electricity? So you tell me what's going on there. Okay, now just to show you, right, if I take my electrodes and I touch them, there is some conduction of electricity going on there. I separate them, none. So once my electrodes are not touching and they're in a substance, right, you should see a difference when it is conducting as opposed to when it's not conducting. So that's going to be all for our lab today. You are now going to do up a discussion and to tell me a little bit more about what went on here today. All right, so thank you, ladies. I'll join you shortly for your discussion.